Alright, here we go. This is the first video for section 3, chapter 1 in your trig book, which is over the trigonometric functions. There are a total of 6 trigonometric functions that you should have learned by this point somewhere along the way, either in Algebra 1, Algebra 2, or Geometry. So we're going to make a slight adaptation. We are going to be talking about this in terms of an angle in standard position. So keep in mind that when we put an angle in standard position, we put one side of the angle on the positive x-axis, and the other side marks how much of a rotation we have made. So our angle, theta, will be the angle measure of whatever we are talking about here. Keep in mind that somewhere on this angle is the point xy. And remember that Cartesian coordinates, that tells us that if we drop the altitude straight down to the x-axis, that this will be x units and this will be y units. In this case, x would be a negative number and y would be a positive number. Now the last thing we're going to add is that the distance from the origin to the point xy we're going to define as r, the radius. And we need to keep in mind that the Pythagorean theorem states that x squared plus y squared will always equal r squared. So we have 6 trig functions that exist that we should have learned somewhere in geometry or algebra. The 3 basic trigonometric functions, which are the sine, which is actually spelled S-I-N-E but is abbreviated S-I-N, the cosine, abbreviated C-O-S, but is spelled co and then sine, S-I-N-E, and the tangent. Now you learn these using SOHCAHTOA and using right triangles in algebra or geometry. We're going to be a little bit more specific. We're going to use this general picture. Sine is always going to be y over r. Cosine is always going to be x over r, and tangent is always going to be y over x. And that still fits SOHCAHTOA because in theory, this would be the angle that we're looking at, which means that y would be your opposite, x would be your adjacent, and r would be your hypotenuse. And SOHCAHTOA, which is how we should have learned this in algebra or geometry, says that sine is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, x over r. And tangent is opposite over adjacent, y over x. So that should not be something that really is a problem for us. Now I'm going to remove all that SOHCAHTOA stuff from the screen. And then we're going to talk about the 3 reciprocal identities. So that's going to take me a minute here. Let me get that removed. Okay. Our 3 reciprocal trigonometric identities are the cosecant, the secant, and the cotangent. And they're called the reciprocal identities because they are the reciprocals of sine, cosine, and tangent. Cosecant is the reciprocal of sine, meaning it is r over y. Secant is the reciprocal of cosine, meaning it will be r over x. And cotangent is the reciprocal of tangent, meaning it will be x over y. So these 6 are probably something that you need to memorize. That being said, it will be provided to you on a reference sheet for most of the times that you need it. So mostly you just need to mark this particular slide in your notes as being important. Let's do an example. The terminal side of angle theta in standard position passes through the point 815. Find the values of the 6 trigonometric functions of angle theta. So, let's draw a picture. Here is the initial side of our angle. Our terminal side passes through the point 8/15. So if we drop that vertical down, we have x is 8 and y is 15. Now, in order to do this, we need to figure out r. So step 1 in this process is find r. And we're going to do that by using Pythagorean theorem. X squared plus y squared equals r squared. So we have 8 squared plus 15 squared equals r squared. That would be 64 plus 225 equals r squared, which would be 289 equals r squared. So r is the square root of 289, which even though in algebra we say that's positive or negative 17, that has to be a positive number because r is a distance. So r is 17. Now once we know what r is, our second step is to write out the values of all 6 trigonometric functions. Okay? So here we go. We have 6 of them. We have sine theta, which is y over r. That would be 15 over 17. Cosine theta is x over r. That is 8 over 17. Tangent of theta is y over x. That is 15 over 8. And then we have our 3 reciprocal trig functions. We have the cosecant of theta, which is r over y, or 17 over 15. We have the secant of theta, which is r over x, or 17 over 8. And we have the cotangent of theta, which is x over y, or 8 over 15. Done. Now there are some things that can make this more difficult, so we need to make sure that we discuss those. We're going to do 2 additional examples of this before the end of this video that should illustrate the 2 issues that could come up in this process. So here we go. Same directions. Terminal side of angle theta in standard position passes through the point -3, -5. Find the values of the 6 trigonometric functions of angle theta. So again, we're going to draw a picture in standard position. So we have one side on the positive x-axis. The other side passes through the point -3, -5. So that's somewhere in the third quadrant, -3, -5. Now what that tells us is that x is -3 and y is -5. So we need to find r. Okay, so step 1, find r. Remember that r squared is x squared plus y squared. So r squared is -3 squared plus -5 squared. Remember that when you square a negative number, the square of a negative number is a positive number. So that would be 9 plus 25, which would be 34. So this illustrates our first issue, which is, what do we do when the number that we are taking the square root of is not a perfect square? Well, we need the reduced root. So in this case, that would be the square root of 34. That is our r value. So r is the square root of 34. Do not turn that into a decimal. If you do, you will immediately have your entire answer counted wrong. So again, we have 6 trig functions. And we have definitions for them based on x, y, and r. So we are going to write out all 6 of our trig functions. All right, so y over r is sine, that is negative 5 over the square root of 34. Now the problem with that is you are not allowed to leave the square root of 34 on the bottom of a fraction. So we have to carry out a process that you should have learned in Algebra 2 called rationalizing the denominator, where we multiply the bottom and the top by the square root of 34. Now all that really does is it moves the root 34 to the top of the fraction and gets rid of the root on the bottom. So our sign would be negative 5 root 34 over 34. The same sort of thing is going to happen with cosine, because we're going to have the square root of 34 on the bottom. So we also have to rationalize that denominator, multiply the bottom and the top by the square root of 34. That would be negative 3 root 34 over 34. We do not have that problem with the tangent. It is y over x, but we do need to be careful because both y and x are negative, which means our answer should be positive 5/3, because a negative divided by a negative is a positive. Cosecant, we don't have that problem because the square root of 34 is on the top, and there's nothing wrong with that. So we would just say negative root 34 over 5. Wait. Yeah, that's right. Same with secant. We do not have that problem because it's root 34 over negative 3. So that's just the negative root 34 divided by 3. And then with cotangent, we don't have that problem because we just have the 3 and the 5. They are, however, both negative, so you need to make sure your answer is positive. And that would take care of all 6 answers. So that's what the first problem we could run into is if r is a square root, we might have to rationalize some of the answers. The other thing we have to watch for, we're going to do another one here, will show up in this example. So here in example 3, which we're waiting for the change page, there we go. The terminal side of angle theta in standard position passes through the point negative 6, 8. Find the values of the 6 trig functions of angle theta. So again, we're going to draw a picture. Negative 6, 8 is somewhere in the third quadrant. So we draw a picture. Drop that vertical. So we have x is negative 6, y is 8. So we start off by finding r. R squared is x squared plus y squared. So we have negative 6 squared plus 8 squared, which is 36 plus 64. So r squared is 100, which means r is the square root of 100, which is 10. So r equals 10. Step 2, we're going to write out those 6 trig functions. So sine, which is y over r. Cosine, x over r. Tangent, which is y over x. Cosecant, which is r over y. Secant, which is r over x. And cotangent, which is x over y. So the other issue we could run into is when we write this out, y over r is 8 over 10. That is not a final answer because it has to be reduced. If it can be reduced, it has to be reduced. We can divide the top and the bottom by 2. So the other issue we can run into is we can forget to reduce. That should be 4/5. X over r is negative 6 over 10. Same deal. Those are both divisible by 2. So we should have negative 3/5 for our cosine. Our tangent would be 8 over negative 6, which would be negative 4/3. R over y would be 10 over 8, or 5/4. R over x would be 10 over negative 6, or negative 5/3. And cotangent would be negative 6 over 8, or negative 3/4. Again, you have to remember to reduce. If you can reduce, you must reduce. And the other major issue is you are not allowed to leave square roots in the denominator. That does it for the first section, first part of section 3, I should say.